Hello friends, welcome to my channel. So today in this demo video we will learn about default provided DBT materializations. Uh, to understand the DBT materializations we need to cover a small concept of data refresh types in case of batch data processing. So after that we will see the demo of implementation of DBT materializations. So let's go to the next slide. So in case of batch data processing, primarily there are two types of refresh we perform. One is full refresh, which is also called as truncate plus insert, in which we truncate the data from the target table, and then whatever is received in the source, we simply populate that into the target. Another one is incremental refresh. The incremental refresh, we do not delete or truncate the data from the target table. There are multiple scenarios. One could be like append only, in which we keep the data from in the target table, and whatever is received in the source we simply append it into the target table. Or there can be a requirement or scenario for merge, in which for matching keys between source and target we need to update certain records, and then for non-matching keys between source and target we need to append from source into the target. So we will see the implementation of both these scenarios today. There are primarily five type of DBT materializations provided by default: table, view, incremental, ephemeral, and materialized views. There is also an option to create your own DBT materializations, but that is a advanced concept and is beyond the scope of this demo. So to keep the length of this video short, I will explain first three materializations, table, view, and incremental in this video, and then I will create another video for ephemeral and materialized views. So let us go and see the Snowflake and DBT instance now. So this is my Snowflake instance where I have created an analytics database which is based on a Medallion architecture. So I have raw reporting and STG schemas. Uh, I'm simply refreshing that right now there is nothing in my STG schema. This is my DBT instance. This I have already configured. So whatever models which I create between the or in the STG directory will be created in my STG schema of Snowflake. So let us first see the table and view materializations quickly. So I can create here a new file. I can give the name mat underscore table.sql. So we can define the configuration block here. Config materialized equals to table. So we will create a random SQL query to generate the dummy data. So let us write select sequence 4 as C1, some random string rand str of line 5, random as column 2, and then we also create a, let's say, timestamp column. So current timestamp as created timestamp from, we will use the generator function to generate, let's say, 10 rows for now. So this is a very simple example of our table materialization where we are generating the dummy data. So right now there is no table in our STG schema. We simply run this dbt run select mat table. So the important thing to note about a mat table is that it executes a CTAS statement underneath. It is a create and table statement always, and this can only be executed in full refresh mode. There is no incremental mode for table materialization. So if we go here right now, refresh our, so we will see select star from analytics.stg.mat table. If we run this, we will see that 10 rows has been populated with some random strings values as well. Now we can create a view materialization on top of it. So what we will do, we will create another materialization or another model with materialization view.sql. As always, first will come the config block, config materialize equals to view. We will create a simple view on top of our mat underscore table model. So select star from ref mat underscore table. This is a very simple view. So if we execute it, dbt run, right now there is no view in our STG schema. Once we execute it, it will create a view. So it has executed. Again, the view materialization always executes create or replace statement using the model SQL query. So right now, if we refresh it, we see a view has been created. We can also check the definition of the view. It is a select star from mat underscore table. Third comes is your incremental materialization. So for incremental materialization, we need two models. One is source, another one is target. So this mat table we will use as a source, and we will create a target with incremental type of materialization. Create file mat underscore incr. As always, the config block will come first. Config materialized will be incremental. We will be consuming data from the mat underscore table model. This is the simplest example of incremental model. So if we run it, right now the mat underscore incr table does not exist in our target schema. So let us see what it executes. So first DBT checks whether the target table exists or not. If it does not exist, it simply executes a CTA statement. So if we now go here, we will see that our incremental table has also been created. Select star from analytics.stg.mat underscore incr. But what happens if our target table exists? So let us repopulate the source table now. Let us create 20 records, but because we already have the rows from 0 to 9 ID, so we apply a condition here where C1 is greater than, let's say, 10. So if I save it and I run the mat table model, it will repopulate my mat underscore table with records 11 to 19. And now if I run my incremental model, this time my target table already exists. So the SQL statements will be different, which are executed. So the first statement will be that DBT will create a dummy table with underscore underscore DBT temp, and it will store the results of the model SQL query into that, and then it will insert all the records from that temporary table into my target table. So if I see here now in my incremental, I will see that I already has the historical data also from 0 to 9, and then I also have the current data from 11 to 19. So this is a simple operation of append only, but several times you also need to perform the merge operations, in which you need to update the values for existing keys and then append the non-existing keys into the target table. So how do we implement that scenario? Let us see that now. So for that, as I said, we need to update the values for the matching keys and then append the non-matching keys. We need to define another configuration, which is a unique key in case of incremental materialization. In our case, it would be C1, but it can be a list of multiple columns if you have a composite unique key. Now let us save this. What we will do is we will reload our table, source table, with 30 records this time, right? And let us execute this. So if we execute this, it will reload our source table. Let us note down the value of 0 here. and the timestamp, and also let us check before executing the incremental materialization the value of 0 key is same and timestamp is 0055. So now after executing the temporary or after executing the incremental materialization, the values for existing keys, that is from 0 to 19, should get updated, and we should also have the records for non-matching keys which are beyond 29. Is there any record beyond 29? Yes, beyond 19. So let us run the incremental materialization now. Now this time, because our target table already existed, so the SQL statements will be different which got executed this time. As a first step, it will create a temporary table in which it will simply store the result of the model SQL query. As the second step, it will execute a merge statement using the key, using our the key between the temporary table and the target table. And for matching cases, it will perform the update. When matched, then update, and when not matched, then insert. So let us check our results now. So right now the value for key 0 is same as in the source table, and timestamp also has become 17, which is from the source table, and we also have the data for keys which were added to our source table. So this is how we perform merge operations. There are multiple strategies which you can use to implement your incremental materialization. For example, right now we saw an example of merge statement, which is by default. There are other materialization or incremental strategies provided, like delete insert is one, which I will show you right now how to use this. In case of merge strategy, there comes a few additional options, like you can suppose a scenario that you have 100 columns in your target table, and in case of matching keys, you only want to update a few columns, let's say 5 or 10 columns, then you can mention those columns here and only those columns will be updated. In the reverse case, suppose you have 100 columns and you want to update 90 of them, so instead of mentioning 90, you can use merge exclude columns configuration and mention only 10 of them which will be excluded. So now for delete and insert, where this is used, sometimes you may want to avoid the update statement during due to the performance scenarios. That's where delete and insert comes handy. So what it will do is, for the matching keys, first in the target table it will delete the data or records, and then it will insert the complete data from your source into the target table. For example, if we need to implement this strategy, all we need to add here is another configuration which will be incremental strategy, and we need to mention the strategy here. As simple as that. Now suppose I insert 40 records into my source table. Now I have 40 records in my source table up to 39, and in my incremental I have only up to 19, or if I simply perform up to 29. So now if I run my incremental model, what it will do is, the SQL statements executed underneath this time will be different. The first step will be same. It will create a temporary table using the SQL query of the model. Then instead of performing a merge, it will first perform a delete on the target table using the matching keys, and then it will simply insert whatever is there in the temporary table into the target table. So this time our target table should match. It has up to 39. So that's how you can implement different materialization or incremental strategies. One another important concept which I want to cover is the availability of a macro, which is incremental. Is incremental. As I said, the incremental model can be executed in two different modes. One is full refresh mode and another one is uh, incremental mode. In case of full refresh mode, it always performs the CTA statement, and in case of incremental mode, it gives us an option to add additional conditions uh, within the incremental model. So this particular macro is incremental, always provides true if you are executing an incremental model in incremental mode. But if you are executing your incremental model in full refresh mode, this macro will provide you a value of false. So let us add one condition here that uh, we want to use a condition on create timestamp, which is created timestamp, where created timestamp is greater than select max created timestamp from this. This is a helper here in this case, which will refer to the same model, target model. So if I save it and if I run it, let's say first we need to update our source model. So let's say if I add additional column here, let's say DBT as created by, and I also generate, instead of 40 I generate 50 records now, right? So if I run my table now, I think I had a typo there, which is DBT, right? This is the SQL query. Is there any compilation? No. Yes. So I saved it. Now I am running my materialization table. It is failing with the reason it has unexpected additional bracket. One second, let us check. So this I am showing how to debug. Okay, it is saying in the incremental I have given something wrong here. Okay, this is the typo here. So right now, yes, I think it will execute this time. Yes, so my table mat underscore table has got the data. It has got the new column as well this time, right, which is created by DBT, and it has now values up to 49, whereas in my incremental I do not have the created by column, as well as my records are only up to 39. So now if suppose I want to have this column also, suppose I run this incremental model in the incremental mode, so what will happen? So statements it will execute are: first, temporary table. It will include my statement which I have given inside the block because I am running it in incremental mode, and then those simply delete and insert. So all the records will be inserted and I will have the data for all the 49 values. But again, the additional column is not added. So another there are multiple options to achieve this, that whenever the schema of the source gets evolved, the same changes are propagated to my incremental model. One is schema evaluation. Otherwise, another option is that you can run the incremental model in the full refresh mode, in which case it will be executed as a CTAS, which I will show you right now. So incremental, all I need to add is one more helper, full refresh. So if I run my incremental model in full refresh mode, the is incremental macro will return false, and that particular line of code will not be included, right? So it will execute as a CTAS only. So right now, if we see here, we have our new column as well, 49 records. Yes, so that's how we can implement multiple scenarios using different combinations of strategy, is incremental macro, and the types of materialization. So this is all for this video. If you find this video helpful, please like it and subscribe to my channel. See you in the next video. Thank you guys.